Hey guys, good evening. Can you hear me? Is my voice loud and clear? Or
Yes, sir.
is
Good evening.
okay? Okay. I'm just muting everyone. So if you have any questions, you can just unmute and ask. No, I'm because it's like creating noise. Yeah, just hear my screen. Okay. So in the module 3 of this course on MATLAB programming and MATLAB programming for numerical computation. So now, we are actually entering into the uh, course in a sense. Uh, I mean, we are going to, we have started learning about numerical methods from this module. So last, I think 2 weeks, right? So last 2 weeks. So we have uh, just seen about these things, introduction to MATLAB and a few examples of how to write a script, how to write a function, and how do we use loops, for loop, while loop, and we have also seen conditional statements like if else. So all these things we have discussed. So this week we are going to learn about errors and their approximations. I hope you have gone through these lectures. So we have, I think, about 4 lectures. So, so the first lecture in this module was about errors in numerical methods. So, so this is a Maclaurin series. So Maclaurin series is just uh, uh, a special case of Taylor series. So what happens is like whenever we do any kind of computation, say using a programming language like MATLAB or any other programming language, whether Python or something else. So inherently, these programming language cannot do an analytical solution, like cannot give you an analytical solution. Like if you are asking it to give a square root of something or a square of something. So what these programming languages do is, so they use this numerical methods to compute in the background, and they will give you an answer which is like a approximate answer. Uh, like you cannot say like maybe there might be cases in which like the uh, answer from the numerical method matches with the uh, uh, exact or the true result of which the problem which you are doing. But numerical methods like are mostly like approximations. Uh, and they all like mostly they give you approximate solutions for to whatever you. So we will learn how these numerical methods work. So maybe I think next week we are going to see about differentiation, numerical differentiation, numerical integration, and all sort of things. So but here we are just in this module we are just learning about the errors, various kinds of errors that can occur uh, when we are dealing with this numerical methods. So one, uh, this is a So this Maclaurin series is giving you an approximation of this exponential. So e power a. So this is giving you a polynomial approximation of this exponential. So 1 plus a square by 2 factorial plus a cube by 3 factorial plus so on plus a power n by n factorial. So if you compute this, uh, if you compute this e power 0 uh, 0.1, the exact value, and compare it with the Maclaurin series, you will get an error. So there will be an error. As I said, there will be a error between the true value and the approximate value. So if we increase the number of terms in this Maclaurin series, like suppose if I take some like 100 or suppose if I take initially I take 100 terms and then I say like I want more accuracy, then I have to what I have to do is I have to increase this size of this number of terms which I am taking. So if I increase the number of terms, then my error, this error between the true value and the approximate value which we are calculating by this Maclaurin series will get reduced. So we have seen this Maclaurin series. Yeah, uh, this is the same code which was discussed in class. So we have written a code. So I'm just using this CLC and clear so that if there are any already values there are stored in my. You can see that there are already some values stored in my workspace. So variables stored in my workspace. I don't want to interfere in my program which I'm running freshly in this script. So I'll include these lines. CLC. CLC means it clears this command window. Clear means it will clear all the variables in the workspace. Close all means like if you have any plots which you have generated, those all will also be closed. So these are these. That's why we use these three commands. So like I don't want the other results like if I have run something before to influence in this program. So otherwise you can run in the command window itself, but I'll prefer writing this in the script itself in my first three lines so that I won't forget those things. So here I have done this uh, uh, I've written this code. So for finding the exponential value of e power 0.1. So now we are calculating the value of 0.1 using this for loop. So let's say I'm taking here 5 terms. So 5 times using the Maclaurin series. And I also have this true value, which is exp of 0. So don't forget this, like EF, I am saying here, this is the true value, like exp of 0.1. But internally, what MATLAB does is also a numerical method only, but it will be like very precise than what I am doing here, like using 5 terms. So we can say like this is a true value. So it's not exactly true value, but we can say that this is a true value. So with like very fine precision, it does the calculation. So I can say that this is a true value. So then I have the error true value minus exponential value. So exponential value is nothing but the value which I have calculated using the Maclaurin series. So like we have seen this. I won't explain this for loop, like whatever happened. So like we have seen that say editor. So now if I run this, now you can see that all the workspace and this command window is cleared due to CLC, and all the workspace is like is also filled with fresh variables because I have told clear uh, to MATLAB to clear all the variables. So if I calculate the error, now you can see that the error. So I am taking here 5 terms. So if I take like only one term which is one, like I'm just not yeah, yeah, only one, if I'll get this error. So I am taking two terms, my error is getting reduced. So it's like 0.005. If I'm taking three terms, it is getting even reduced. So if I'm taking four, five terms, so it will keep on getting the value of the error will be keep on getting reduced as the number of someone. Oh, is my English uh, not clear? I don't know. Do others have a problem with my English, or you are understanding? You can tell me in the chat box. So I'll try to maybe slow down a bit. I don't know. I don't know how to explain. Like maybe I don't think I the high speed got that. Okay, fine. Okay, so like as I said, like with increase of number of terms which we are taking in the Maclaurin series. So one, two, three, yeah. So if we are taking like more number of terms, like if let's say if I take only these two terms, my error will be I'll get some error. If I take these three terms, I'll get an error which is lesser than the previous error. If I take these four terms, the error will be even more lesser. So if you take a more number of more and more number of uh, terms in the Maclaurin series, your error will get reduced and you will go as close to the true value as possible. So here you can see that like after I think uh, one, two, and three. After three, you are like going very close to the figure. So that's how it is. Like numerical methods, uh, if we are dealing with numerical methods, so as like we have to make a trade-off. Like you can't go like we can't take like some thousand number of like let's say some thousand or 10,000 terms because it will be it will give lot of computational load to my computer. Like now, computer has to crunch the numbers and it has to do the
Up to what time?
calculations. Yeah, somebody was speaking, right? See, it's not compulsory for you to attend this courses. Like it's a problem solving session. If you are like, if you want to attend, then you can attend. So it's not compulsory. Like there won't be attendance or something. So it's just
But up to
to
what time,
clarify
sir?
what.
Up to what time the classes?
So this class will be going on till 9 p.m. So it's like it's a 2 hour session. We started out around 7. So we'll go on till 9 p.m. So,
Okay, sir.
so if you want to attend, you can attend. If you want to, like, if you don't have any interest, like, you can uh, drop, you can drop the call. Or, like, if you have some time, like, you can't sit for 2 hours, then you can sit for, like, whatever the time uh, uh, you want, like maybe like let's say you are free till 8 p.m. then you can uh, read the call or take it. So like I won't be taking any attendance or something like that. So it's not a compulsory thing that you have to attend. And also like there are also other two sessions uh, which are going on. Like if you don't have time today, like you can probably uh, you also help in giving those idea to assignment. So the thing is like I have been instructed, like we have been instructed to not solve the assignment questions. Okay, so I can give some like similar questions. Uh, like if you ask me some like similar examples, we will solve. Like the assignment solutions are like not very tough. Like you can solve. Like if you are listening to the lectures, you can solve them. So those are not very tough. So probably if you want me, uh, like if you have any questions, you can ask me in the chat box. I can clear a particular question, but like those exact questions in the assignment, I won't solve. So that you have to solve because like those are graded, right? Like you will get the grades at the end of the course based on the assignments and also the final. So someone, K. Prasad Babu, you want to? Yeah, I didn't understand your question. How to write the code for assignment for just related, not exactly. I didn't. I didn't understand. You can you can unmute and speak maybe.
Sir, just a second, sir. I will let you know, sir, what exactly I need.
Okay. Yes, ungraded assignment, practice assignment questions can be solved. That's not a problem. I can solve those problems.
So the thing is how we can write the Gauss-Seidel method code, sir.
Gauss-Seidel method.
Yeah,
So
yeah,
the
sir.
Gauss-Seidel method is not discussed in this module, right? Maybe I think uh, maybe in the next lecture, I'll just see if there is.
Yeah, yeah, sir.
Okay, Mark, we are directly going to, I think, yeah, Gauss-Seidel method is there, right? Fourth week.
Yes, sir. Yes, sir. Fourth assignment, sir.
Yeah, yeah. So it's like this today's session is like we are discussing about errors and approximation. So this is like this session is related to the third
Got
week
it,
of
sir. No
assignment.
problem. No, no problem, sir. No problem, sir. No problem.
Yeah. So I haven't prepared the like anything for Gauss-Seidel method and all. So next week
No.
on Tuesday we will discuss about this Gauss-Seidel method and all this matrix.
Okay, sir.
Uh,
Sir,
yeah,
if, don't matter, sir. By any chance, any built-in functions are there, sir, for Gauss-Seidel method?
I think so. There will be built-in functions. Maybe you can search Gauss-Seidel uh,
Sir, sir.
MATLAB. But I won't recommend you to use this inbuilt functions because uh, that is not the objective of this course. So you have to learn writing these codes.
Okay, okay, sir. No problem, sir. Thank you, sir. Thanks for the
Yeah,
response.
yeah. So please try to learn by watching the lectures and then try to code from them. That will be helpful. Like there will be inbuilt functions uh, inbuilt functions. There are no inbuilt functions. Like you can go to MATLAB's exchange will be there. MATLAB has a community on the MATLAB website. Like I'm just searched, right? So you can see that here MATLAB Central. In this people will have, like, a lot of people might have shared these codes already. So there will be a lot of codes shared. Like, you can download these codes and you can copy and run it. But I won't recommend it. So, sir, not understand problem 4 of ungraded assignment. Using the code given question. Graded assignment for the civil. Ungraded. Okay. I'll just problem 4. This one, right? McLaurin series. This
Yes, sir.
problem will
Yes.
be okay. McLaurin series. Oh, this is there is a code given.
Yes, sir. इस कोड को जब रन कर रहे हैं तो उसमें सर एरर दिखा रहा है.
Okay. Let's copy this. Ah, you have to complete this function. This is like incomplete function. It's not written completely. We have to complete this. So it's written, right? You may start editing here. You have to write still. So all the values and just start. So here in this function, see we are first uh, taking x. So whatever, like, there will be a vector x which we will define on all these values. We are going to do powers, like, individually. Yeah. And then we will also have a denominator. So numerator is like, you have x power 1, x square, x cube, x power 4, all these things in there. And then we will have denominator as, uh, let's say, uh, 1 factorial, 2 factorial, all this. So we have to do, uh, we will get all the terms and we will store this in a vector. So, uh, so we'll have 1, then we'll have, so what is this? So where is they have given, right? So see, so this is the vector which we are saving here. So 1 x, x square by 2 factorial, x cube by 3 factorial, and so on, and x power n by n factorial. So in this function, so in this vector, there are uh, all the possible elements which can come in a Taylor series. Like if you say this is a Taylor series, like these are all the terms in the Taylor series of e power x. So, but in sin hx, we will only want this. We will only want the odd terms here, like odd, not odd terms. Here, these are the even terms. So I want the second term, I want the fourth term, and I want the sixth term. So from this vector, I have to take all the even terms and sum them. Then that will give me the value of sin hx. So in this code, we have they have given this vector, they have defined the vector, but the remaining part is not given to you. You have to write the code. So if I want to, let's say, uh, basically these are odd terms only, right? X cube, x power 1, x cube by 3 factorial, x power 5 by 5 factorial. So I'll just say odd terms is equals to, in this odd term, so I have this vector. So in this vector, I have to take from the second element and in steps of 2 till the end. So what I am doing here in this vector, I am taking only the even terms in this vector and I am storing in this odd terms vector. Okay. Now I have got. Now what I have to do? What is the next thing we have to do? So I have got the required terms which I want for the value of sin hx. Okay. Now I have to sum all these values. Now I have x cube by 3 factorial plus x power 5 by 5 factorial plus x power 7 by 7 factorial. So all these sums I have. Okay. Now I have to sum all the values in this vector. So sin h val, which is the output of my function here. Sin h val. Okay. Sin h val is equal to sum of all the contents in this odd terms. Not all the elements in this. Okay. So now my function is complete. I'll also write this. Okay. Now what have they asked in the question? I'll just say CLC here. Mm. So in the question, they are asking this ML sin h 2.5 comma 8, right? Let's see. My function is stored. Now you can see I'm getting this value sin h value. So if I am taking 8 terms, the value of sin h 2.5, if I'm taking 8 terms, is 6.039. Is this right? It's right. 6 point. Just see, the answer is like the range of the answer which they are accepting is 6.0 to 6.1. So what is the answer which I'm getting here? 6.039. So this is the right answer. So you have to add this two lines to the code. So it's if you run only this the code given which they have given, you will not get the answer because the code is incomplete. These two terms you have to add. You can see, right? So here the function is giving some output value. If the code is not having, if the lines of code is not having this value, how will it give you some value, right? Right. So here we are getting this value from doing the calculations in these lines of code, and then my function will give me an output by taking this value. Then I'll get the answer. So if you do, so we have to add these two. So that was the error I think you were doing, right? So you didn't write the two lines, right? Was that the problem, Parna? Now is it solved,
Yes, sir.
Parna?
Actually, I was trying to solve the problem in the graded assignment. It has a cos hx instead of sin hx. In
Ah,
that,
okay.
we have alternate plus and minus signs. I think there
Hmm.
was some error in my coding that I was writing down there.
Ah, okay. But this is, I think this is fine, right?
Yes, sir. This is fine.
Okay. That you have to figure out. Maybe you need to
Yes, sir.
get the logic. You will get your logic right. Then you will
Yes,
get
sir.
it.
Thank you, sir.
Okay.
Excuse me, sir.
Yeah, Nasir.
Sir, the same that is a non-graded assignment itself.
Okay.
Actually, 12th problem which you just showed, I solved and I got it. Can you kindly check 14, sir? I, I after submitting, they gave some range of answer, which is I'm
Okay.
not getting because only we are changing the value. No other code, no nothing to go with the code.
Oh, this
Just it
one.
is, yeah, 14 and 15. In place of 2.58, it is 1.4 and 5. So I don't think code is going to change. Am I right? Only the
Ah, yeah,
value we
same
have
code.
to
Yeah,
change.
nothing changes.
So, yeah, the value which they have given after
Hmm.
I submitted, it's not many. Can you kindly check it, sir, once?
I'm getting 1.9022. Okay.
1 point?
9022. Yeah, it's coming in the range only. There's no error here. So,
1.90, sir. Can you just show the code, sir? What you have
yeah,
shown?
so you can
Forever.
see
I
the
will just zoom in. Okay, I will take a screenshot of this. And sir, one more doubt.
yeah.
Actually, in non-graded assignment itself, question number 8, when we are
Okay.
checking the error, so
Hmm.
not error, approximate value in question number
Okay.
8, for almost all we are getting 0.9146. Even yesterday when Abhimanyu sir also took, we saw the same value. Now my query is, when the approximate value for all the range of h, that is from 10 power minus 2 to 10 power minus 8, when it is 0.9146, because today what I did, I tried by giving each particular value, means approximate value at 2, 3, 4, 5, 6 up to 8. Then also it was 0.9146, but error is differing. So can you just make this
Okay.
understand why, how, even though the values are same, how come errors are varying?
Okay. We will do one thing. I will just code this. So let's say this. I'll just name this. I'll just start and edit differentiation. So I have to calculate the differentiation for 2 power x using the 3-point backward difference model. So I think in we'll learn about differentiation, uh, more details about differentiation. I think in the fifth or sixth module, I think we are going to learn. So for now, you can just remember this formula. So this is like I am taking 2 points. I am taking 3 points and calculating if I have, let's say, f of x, I am taking f of x plus h and I am taking f of x minus h. These 3 points, and I'm trying to calculate what is the differentiation of f of x. So that formula is this. This is just like like just you have to take 3 terms in the Taylor series, uh, and uh, you can derive it. So it's not a difficult thing. So maybe I think in the uh, fourth fourth module, fourth is the next. I think fifth module maybe we can see numerical differentiation techniques. So we have this RK4, all these different kinds of numerical differentiation. So edit differentiation. Set differentiation. We start the script. So I have f of x. So uh, I'll just define the function definition. So this is one way of defining the functions in MATLAB. So I have this function f of x. I'll just say f here. So f is equals to odd x, and that is 2 power x, right? 2 dot power x. So I'm just using x dot here because I want element wise uh, this element wise powering. So my x will have a lot of values. I want x might have a lot of values. X might be a vector. So I want each uh, value of x to be powered with 2. So 2 power, let's say 2 power 1, 2 power 2, 2 power 3. So this is one way of defining the x. So this is one way of defining function in MATLAB. So here your input is x here. So this function is a uh, uh, defined in terms of this independent variable x. So the independent variable has to be written like this, or in these curly brackets. Sorry, these small brackets. You have to write the independent variable, and then you have to define the function whatever. Then they have also given us this f dash of x, right? So I'll just say f f uh, f dash. Okay. So f dash is equals to 2 into uh, 2 power dash x plus log f. It's not plus, right? It's into log. And this is also a function of x. So this is also defined here. Done. Then we have this value of x at which we want to find out. That is x value, which is 0.4. Okay, semicolon. I am giving semicolon because I don't want to print it. I want to calculate this at various step sizes, which is 10 power minus 2 to 10 power minus 8. I'll just say, uh, so I can use a function here which is log space. So log space will give all these values, which is minus 2 to minus 8. And there will be like 7 of this. So it will give me all the a vector with values from 10 power minus 2 to 10 power minus 8. So all the values will be given. So it's like just like we use linspace. So log space is also a function which we can use. So if you are like if your values are coming in powers of 10, then you can use this. So log space is a function here. Then we have what do we have? H value we have. H value have we defined? Yeah. Okay. Then we'll define an array for errors and we'll store like a null array. And then we have to compute this derivative, right? I'll just write a comment. Derivative computation. Okay, 3 point. Yep, 3 point back button. Sorry, 3 point back. So I'll run for I'll create a loop which will cover all the values of h which I have given. So length of h values. So for each value of h, I want to for different step sizes, I want to calculate this. So this is the h value, right? Like if I have different h values, what will be my differentiation? So for each value, I'll calculate. So here I'll extract the value, each value for like say for first iteration, my h value will be h. For second iteration, it will change because the value of I will be changing. And then I have to calculate this f. F I will say f solution, or like f you can give f differentiation, or let's say you can say f diff approx, because this is an approximate way of one. So now I have uh, 3 into f, 3 into, yeah, 3 into f minus 4 into um, sorry, f of something which I have to give, f of x val. This is a function of x, right? So f of x val 4 into f of x val minus h. This is the x val minus h plus f of x minus 2 x val minus 4 into close the bracket. It is closed. And in the denominator, I have 2 into this. So I have calculated this. Then I want to calculate the error which I have already let's say I'll just take error. Error will be absolute of whatever which we have which was given here f dash. So which is the absolute or the true value of differentiation is f dash minus 5 if it comes. Now I'll store this error in the errors vector which I have created, or you can say errors is equals to, yeah, and then I'll end this loop, and now let's see how it will run. Let's see if there are any CLC clear and all that. Doing some and columns. Okay, sorry. I is equals to 1 is any other. Okay, sorry. This shouldn't be there. Coming from Python, so I'm just needing. In Python, we do this semicolon after this. So still there is another.
So HVAL.
Ah,
Uh,
okay, okay.
somewhere
H1
yes,
center.
yes, you have used.
Okay. Yes, that's right. Okay, thank you. Now let's run it again. Again, it is open. Again, 15. Invalid is the password. Oh, okay, okay. Okay, this is the error. I don't have to. This, okay, this should come after the first the dot, then our the caret symbol. So I have written the other. Sorry. Sorry, yeah, yes, sorry. This is a function, right? So x var. Okay. So now I think it is here. We have three of errors. It is a function. So I have to give the value, some value to the function, then it will give me some value. Otherwise, okay. So let's see what we have calculated. Uh, First question is report the approximate value of the dash of x, but h is 0. So we'll just see. So there is only one value of x. FD approx. Okay. I'll also create some other vector. I'll say solution vector, and I'll save all this. All vector is equal to all vector. Python. Let's see, solve that. Okay. So you were saying that this is giving the same value, 0.99 for all these things, right?
Yes, sir. Even actually, when I go with location wise also, no. For example, this at 1, at 2, at 3, I thought maybe it got round off. So I went for
Yeah, yeah.
at 1. Then also I'm getting the same value. I'm not getting more than 4 digit. But my question is, when it is same, then why our errors are varying? That's my doubt.
Oh, see, inherently MATLAB is showing this value, okay? Uh, so it displays this value like 0.9146, okay? But you will have lot of other decimals after this. 0.9146, something will be there. But it is like here it is only displaying four decimals. I'll just check how. Uh,
Sir, if not, can we just think of using that long format, and that's why I'm recalling long format if we give? I
long,
didn't try this. Now I'm recalling long format. Just
long.
see,
There's the
yeah,
function, I forgot. Long, right?
long format. Yeah, long format.
Space
Space.
format.
After long
Space,
space format.
I don't think, like, there won't be space in it. Right? I'll just check.
Just for
Uh,
just now recalled. Maybe if we can think of.
to- we'll add here, let's see how format is long. Right? Okay,
Oh,
you
yeah,
can see,
correct.
right?
I
So
didn't thought
it's
about this
just
last thing. Yes, thank you,
whatever
sir.
it is, whatever it is showing here uh, before. So whatever it shows here, it's like it is rounded off to four significant digits. Beyond that, it is not showing. Like generally, it is set like that. So if you want, I think you can use this long format thing, or also you can use VPA. I think you can. There is a variable precision arithmetic function is there in MATLAB. So you can set it to uh, give like as many significant digits as you want. Like you can different, like you can put the machine precision like differently. So MATLAB inherently has some machine precision. So yeah, yes. So 16 digits of precision will be there. So you can use this VPA to do different things like uh, examples are also there. Yeah. So you can set the digits. and do like precision you can change and do. And if you want your solution to be printed uh, like with lot more decimals, like then you can use long. I think there will be some other things too. I forgot. Uh, but yeah, that's why you are getting some like all the values were same in the box, but you are getting different amounts. This is the and then we can also do like we can also plot this errors whatever we have got. Uh, say I want to plot, right? So I'll say log plot. So log h wall small h again, minus, sorry, not minus, comma, the errors. So I'll plot the errors and we'll use this representation. That will something like that. I can view the labels also. It's label is equal to step size. And my label is error. Or you can say absolute. If we don't, like we are taking the absolute value, not insert. And I can give the title to my work. Say error versus exercise verb prox differentiation. We are using the three-step 3 point backward. Just wait. So you can see this as the step size increases, the error is also increasing. But here you can see initially, as like the step size decreases, the thing which has to occur is like the error should be like decreasing. This should be the trend. But here it is increasing because of the rounding off which MATLAB does. So we have seen like I think lecture 2 or lecture 3 rounding off. So MATLAB has this inherent precision. Okay, so some least count is there. Like if you are getting some value lesser than that, it won't take. Like it won't be able to take. So let's say if you have like 223.2172, this is an example. So if the least count is 0.00, sorry, 0.00001, so it will only take up to this. Beyond this, it won't take. So that's why rounding off occurs, and due to that, some error accumulates, and due to that, you can see this trend which was occurring. Yes. So truncation is one kind, and rounding off error is the other kind of error which we have seen. So that is the problem which we were seeing. So this is the problem of machine which happens. So it's not some error in your calculations. Okay. So your step sizing, like your step size is going beyond the machine precision which it can take. So that's why this error comes. So there is no error in your coding, but due to the machine's precision, or you can say the least count of MATLAB, so this happens. Any other questions from this practice set you have got?
Sir,
Yeah.
Now, what this machine precision is when said, my
Yeah.
doubt is
Mm.
this example was with respect to numerical differentiation.
Mm.
So my doubt is this particular error that means nothing but what we got no that it was first decreasing and then it is not giving the error properly. Is it
Mhm.
only with respect to numerical differentiation and is it going to also affect numerical integration also?
Uh, See, wherever this thing comes, like wherever your values which you are calculating goes beyond the machine precision, this thing will come. So, like, I won't say trend will be like this, okay?
Oh,
Like, this is with respect to the numerical differentiation which we are doing. But, like, if you are expecting some trend, let's say in integration also, if you are taking smaller step sizes, like, yeah, I think if you are taking smaller step sizes, like more and more less step sizes, you have to get like more uh, like nearer to the accurate solution. I think you will get this kind of trend in your integration also, because if it goes beyond this, like step size goes beyond the machine precision, then your results will vary. Like trend can change.
so it is with respect to MATLAB precision
Yeah,
ultimately.
MATLAB precision.
Well, somewhere I just forgot where no approximation can be good in numerical integration, but not in numerical differentiation. I just forgot that
Okay.
exact sentence. So yeah, just with the spirit, I just wanted to link. This is one. So, sir, one more.
Okay. I'm not
Actually, till
sure.
okay.
Yeah,
Yeah, yeah, sir. You please complete. You please
I'm
complete.
just saying, like, I'm not sure. Maybe I think numerical differentiation. Yeah, I think integration. I don't know. I have to I have to read it once. I think
Okay.
maybe you
Uh,
like what you are saying is right. I don't. Yeah.
because what my thought here is in with now that the concept went just along through again that also was going to NPTEL videos by Iyengar, Professor Iyengar sir, where he
Okay.
uploaded
Okay.
40 videos, okay, classic videos. So there he was discussing. So I just wanted to link whether it is going to be with respect to MATLAB, whether it is going to be error in both the cases. Not okay. So another thing is no till 5 o'clock today. So MATLAB
Okay.
was working, the one which we have got the online version through NPTEL
Okay.
course. But now simultaneously, I'm just trying it out. But even the workspace, nothing is working. So is it something like it was for some a few number of days where we had the access to MATLAB to NPTEL course, or
Oh,
should
did you?
I?
Uh, uh, like, how are you accessing it? Like, you are just going to
Actually,
MATLAB online and you are just logging
no,
in through
actually,
your email
yeah,
ID
yeah.
and accessing.
First it was through portal. Means first we got a mail, no? Through mail it was said you can just
Ah,
go to the link. Then so to that itself I have access. But I don't know from past 6 p.m. No,
okay.
nothing is working. Only file is open, but nothing is working. So should I just post any message to NPTEL
I'll
team, or
just
is it
check it. Just check.
because our entire assignment will depend on this
I
link?
haven't
So
seen,
I'm lost.
but like if you are using the online version, na, you can use I think 20 hours per month. I think. Uh,
Yeah, but it was through
I
NPTEL.
don't know if you
So
have
is it
got some special access.
because we got one mail when we
Okay.
uh, registered, no? Before starting of the course, we got a mail to NPTEL. So, and it
Okay.
was in that mail there was a link. After clicking that link, it went to this. But till today, 5 p.m. it was running.
Okay.
Now, nothing. Even I till then I tried Octave. Even 1 plus 3 also the calculation is
Oh,
you just take
so it is giving you a wrong answer. Huh?
not wrong answer, timeout in Octave,
Ah,
out
okay.
of time. But the old files which I did know, when I'm opening that and when I'm giving it to run, no, it is running the old files in Octave. Uh,
Okay. Okay.
but this all no,
So,
the new even 3 plus 2 also is not running. Then it will be difficult for assignment because I finished all except the last two.
okay. So, what was the mail which you got? Can you tell me about the?
For a while, sir. It was long back when we started, no? I'll just see, can I get that?
So this is like welcome to
And even
NPTEL course.
in this also, no, we can see down
Hmm.
they have mentioned, thank you, MathWork, for giving access to the student.
Okay.
When portal also, we can see that.
Maybe you can refresh it and check. I don't know. I haven't
Yeah,
got that. Hmm.
I went for restart also. I don't know.
Okay, maybe you can check tomorrow. Maybe I don't know.
Okay.
Because this is the online version, right? Sometimes the servers like will be busy or something might have happened.
Okay.
So that that might be the problem. I don't know. I'm just guessing it. Uh,
Oh, in case
you
it
can
continues,
also
should I give any mail? Should I just send any email and to which, in case it continues tomorrow morning also? Can you just suggest me to whom I have to mail in case
oh
there is problem?
you can mail to this. I think you can put it in the discussion forum.
Okay.
Where is it? Where's
Okay.
the discussion?
That is that Q&A. Q&A.
Right?
Yeah.
Here you can probably ask a question. Okay.
Okay. Also the same. If let us suppose I want to go for this sine infinite series will be x minus x cubed by 3 factorial plus x power 5 by 5 factorial. So can you suggest how we can go ahead for this?
The assignment problem.
No, no, this is that was other. I think cos. I think I was for sine.
Okay. So you want like minus, right?
Yeah, that logic if it is known, no. Let us suppose this is
Ah,
for cos.
okay, okay,
Let us
okay.
suppose we'll go for sine. Sine will have alternate sign, no? Plus minus
Yeah,
plus
yeah.
minus.
Can you tell us about that?
Yeah, as I remember, I think we have some other, not for sine.
Uh, this I think you can generate the matrix with plus, plus. I think there can be a way to generate matrix with like some number of ones, in which uh, one will be positive and like next will be negative, positive, next will be negative.
Hmm.
Like if uh, like if like if you have some like one like 1 cross n vector, so this is a 1 cross n vector. You can generate a vector uh, which has 1 minus 1, 1 minus 1, 1 minus 1, and you can do the element wise multiplication. Okay.
Okay, minus one power I type, maybe.
Ah, that you can do, or you can uh, or you can write a if condition. Let's say if I have, here I'm doing the sum, right? Where is this? Sorry, immense image. So here you can kind of do a if else condition. Okay. So if your I value is odd, then you can say add. Okay. Then you can say, oh, sorry, all of these are odd. Okay. Then you can, uh, okay, first you have, uh, first you get these odd terms, and then you can run a for loop, or let's say j in length of odd terms. Sorry, this is J. Again, I'm doing Python code. Sorry. For J in length of what terms? What terms? So what I can do is, if I'm getting, let's say, A is, mm, how to check with MATLAB? How to check if a number is, there will be a function for a number. Okay, good now. I have to use more than this. If mod of J comma 2 is equal to 0, then I'll say, let's say, I'm adding it, right? So, what is this? Okay, sum is equal to sum plus uh, odd term, odd terms. Okay. Else, what I'll do, I'll initialize it for, I'll just say sum is equal to 0. Yes. Then, if this is not even, then I'll say sum is equals to sum minus odd term. Okay. If we are taking odd terms, so this is the function for sign, right? We are taking odd terms. Am I right?
Yes, yes. Odd terms.
Okay.
1 minus x cube by 3 factorial plus x power 5 by 5 factorial. Move on.
Now you can get that. I'll just remove this sign value, sign h value and sign. I'll just okay, sign h only, right? Because I have to write it. But this is the sign value. So, so the odd terms are uh, odd terms should have this. So whenever there is an even term, you are like adding it. So I think even terms should be minus. And whenever there is a odd term occurring in this, okay. So whenever there is an odd term occurring, you have to add. So you can do like this, you can run, and you can get the answer. Just see if this is right. Sin h, what is this? I have done, uh, yeah, PLC clear, out. So sin value is equal to ml, ml underscore sin h. So let's say sin, I can say 0.5, okay, 0.5. Okay, let's say 8 term. I'm getting some. Let's say if I take sin of 0.5. Yeah, so I'm getting right. Same value I'm getting. So this is the absolute value. This is the correct value, and this is the approximate value which I have calculated. There is some error here, you can see. So, so what I am doing here is, uh, this is the, where is it? Yeah. So this is the vector, right? This is the vector. I'll just, so I have these terms. This is the vector which I'm getting. Okay. 1 x square by, I'll just try to 1 x square x x power 4. So there are some other things which I have to write. 5 factorial x cube by 3 factorial. So like that, so on I have up to x power n, right? N factorial. So in this, sin will have only this, sorry, there is also x here. So sin will have only the value of sin will have only the odd terms, right? So I want only x cube and all this. So from there I'm getting this odd term. In this, I take and just stop it. Oh, this will be gone. This will be gone. So I'll have a function like this. So now you can see in this the vector in this vector of odd terms, when I sum for sin, uh, when I sum, it's just write the equation. It will be sin of x will be using the Taylor series approximation. I have x minus x cube by 3 factorial plus x power 5 by 8 factorial plus sorry, 6 won't come 7. Yeah. This is minus 6. So, right. So here you can see the odd, whatever the odd terms which we are odd terms the in this odd terms in this first x is the odd term and then x power 5 by 5 factorial is the odd term. All are having all are getting positive values. So in my code I am saying all the odd terms in this odd terms vector should have positive values. Like it should be added to my total sum. And whatever the even terms, which is x power 3 by 3 factorial and x power 6 by 6 factorial, and all those should be even terms should be subtracted from the sum. So that's what I am doing. And finally, all the after doing all this sum from first to like till whatever the times I'm taking, everything will be summed up in this summed up and stored in this variable sum. And I am printing and that I'm giving and that I'm storing in this sin h value because this is the output of my function. And if I evaluate the function, I'll get the value. Similarly, if like you have uh, what is that? If you have this cos h, right? Like cos x, I think cos x is given in the sign. I guess so. Where is it? It's 3 assigned. Yeah. So in cos value, whatever the values you have to take. So here you can see, here you have to take the all the odd terms. So then you have to do, then you have to evaluate it. So that's the case here, and difference between this, uh, like the same thing you have to do. Like you have to use this kind of condition. You have to use this kind of condition. So instead of using here 2 to end, here you have to use 1 to end. So then you will get the value of cos. Like let's say if I take 1 to end, same thing, like everything will be same. So here also like you can see that uh, even terms are having negative and odd terms are having positive. So nothing will change. I just have to change. I just have to go from 1 to 2 steps to collect all the even terms. I can say like I'll just put it as odd something. So the naming is a little bit off, I think. But yeah, same thing. If I do it, if I run this code CLC, yeah, I'm just giving you the solution for the assignment also. So cost val is a cost val of uh, so my function name of the function is the sin h, but it is giving me a value of cost only. Don't get confused. Let's say 0.8 comma 8 terms and just giving some value. Don't mean to- Okay. This is 0. if I calculate the same value using the, like if I get the true value of cos 0.8, I'll get so this is, so approximate value I'm getting like this approximate value is like near to the true value, of course. So, or like let's say you can say if I want to calculate cos val of like what is the value of cos 90? What is the value of cos 90? You guys know it. Sin h1. I'll say 5 by 2. So I have to give here in radians, okay? Whatever the value. So I'm taking 8 terms in the series. If I calculate the value of this, I should get the value. MH sin ML sin. So I'm getting this value like near to 0, like because of the machine precision. So it's like I'm getting the value near to 0. If I let's say calculate the same value, true value of cos 1, then it is also having some, like it is also giving some value like near to 0. So like there is some error. Let's say if I calculate the value of uh, 5 only, I should give -1. Let's say how it will be. This is -1. If I do it for the same thing, so this is like 6. So the approximate value is like near to -1, 0. So there is some error because I'm truncating the series, right? Like I'm taking 8 terms only. If I let's say if I take some 100 terms here, 100 terms, like 1 minus x cube by 3 factorial plus like that, like if I'm taking 1 minus x square by 2 factorial plus x power 4 by till some 100 terms I'm taking like that, x power 100 by something like that. Then what will be the value of this I'll get? I am getting like almost like the exact value of cos. So increasing the number of terms in the Taylor series or the Maclaurin series will give you a more accurate answer, which is near to the truth. Okay, I think you have got the idea how to code this, right?
Sir, my humble request, can you just,
Yeah.
the PPT which you just wrote, no? Can you just re-explain, sir? PPT, in PPT.
PPT. Okay.
Just linking this with the code
Okay.
for last time. Thank you.
See, let's put this here. Here, can you hear me?
Yes, sir.
Okay. Okay. So, so first we are getting this vector here. Okay. So you have some n terms, and for n terms you have to get the powers of x, right? So for that I am giving this numerator uh, x dot 1 is to n. It means I'll get x power 1. I'll get a numerator vector which will have the values x power 1, x power 2, x power 3, x power 4 up to n, x power n. Okay. Then I also have denominator. So I have to divide this vector with factorial, right? So comprod will give me that. So I'll get a denominator. So I'll get 1 factorial, 2 factorial, 3 factorial, 4 factorial, like that. It will give like lot of values. So for each uh, like up to 1, up to n, it will give like 1 factorial, 2 factorial, 3 factorial, like that. And then I also have 1 here, right? So in the vector, so I have like in the Taylor series, for e power x, I have 1 plus x square by 2 factorial plus x cube by 3 factorial. So all these things. So I'll have 1, and also numerator, each value in the numerator will be denominated by the each value element wise division I have to do, and I'll get this vector. So this is my vector. Okay. Then after that, if I want to calculate sine, or if I want to calculate cos, I want specific values in this. Okay. I want specific values like 1. If I want to calculate sine, like the value of sine, I need only x cube by 3 factorial, and x for uh, uh, x power 5 by 5 factorial, like this only the even terms I want if I want to calculate this sine. Okay. So this is not odd stuff. Okay. So from this vector I am taking out only the even terms. Okay. So here what I am doing, here what here this is odd terms. So if I say from go if I take what I'm doing here, accessing the elements of different elements of vector in this range. So I am saying MATLAB, please take the values from this vector starting from index 2 to end, such that my step after 2 it should be 4, then after 4 it should be 6, and after 6 it should be 8, like that. So my indexing should be increasing by 8. So all those terms will be stored in this vector. So if you do that, you will get this vector. Whatever, like if you want for sine, then you have to do it from if you want for cos, then you will need 1 x square by 2 factorial, x power 4 by 5 factorial, right? So that's why you will say to MATLAB from 1, go from index 1 in steps of 2. 1, I don't want the second term, which is x. I want x square by 2 factorial, and I don't want the third. So I am skipping this step because I am saying my step should be increased by value of 2. So based on whatever the terms you want, you will access all those elements and you will store in this vector. Okay. Then I have to sum this, right? Whatever the terms which I have got, I have to sum this accordingly. Here in this, in sine, whatever the in this even terms vector, whatever the odd terms are there, odd terms means x is the first, means first value, right? So I'm saying odd term. So then x cube by 3 factorial is the even term, because this is the second term in my vector here, even terms vector. Then x power 4 by 4 factorial is the third term, which is again an odd term. So all the x power 5 by factorial, sorry. So all these odd terms have a negative sign. All the odd terms have a positive sign before them, right? So I'm just saying this sum sin x. Sin x is nothing but sum of all these terms, right? So I'm just saying sum here. I'll just start with, let's say, sum is equals to 0. Then to this sum, initially I have some value. To this term, I'll just I'll check if my index if I'll take I'll go term by term. Okay, I'll go term by term. So first I'll check for j is equals to 1. So j is equals to 1, then I'll have x. So x will have, so x is not so if I divide 1 by 2, it's not an you won't get remainder 0. So that's why it is an odd term. So odd term should be summed. So there should be positive. If I take x cube by 3 factorial, which is the second term. So if j is equals to 2, then it is even. So the indexing is even. So the even term should be subtracted from this. So that's why I have done this. So each step, you will go for each term and you will do the sum, and then you will store it. I'm just storing it in sin h1 because my output is like this. I can Like I can just give it like I don't need to write this also. I'll just say sign. Okay. Sign val. Here only I'll say, okay. Sign. Initially I have defined it as 0, and then I'll subsequently add each term. So I add x, then I'll add x cube by 3 factorial, then I'll add x power 5 by 5 factorial. But the signs have to alternatively change. That's why I am using this mod. Like if my index is odd, it should be added, and if my index of the term is even, it should be subtracted. So that's what that is how the code is running. Okay, now you understood.
Yes, sir. Thank you. Thank you very much.
Are there any doubts? Others? Uh, any other people have any doubts? You can ask. So this is a flow. Like you have to understand the flow of the program, like how it is doing. Like, like if you are not getting something, means like your concepts of indexing and concept of accessing the vectors, uh, like concatenation of vectors and like concept of accessing like elements of vectors is not somehow clear, then you have to revise those. Okay, right? Any other doubts from this or something else you have?
So actually, even yesterday I requested the
Yeah,
other yes, sir. I'm requesting you also. The actually whatever the reference book is been mentioned by the professor, we are not
ah,
able to. Some of the books I was able to download from internet, but not
okay.
all. So if you have a soft copy, can you share in the portal so that we can no take the maximum benefit?
The thing is, like, I try to like access those books. I don't have that. Like, I tried like do whatever it is given in this post description. I try to get it. If you look about the course. There are, I think, one text is given, one is textbook is given, and other is a reference book. I tried to access this, but I couldn't get access somehow. Like, I don't know. Like, there is like our institute doesn't have access, and like uh, if you are like using some internet, you have some sources from which you can access. I have tried whatever the sources which I could, but I couldn't get this. Like, but there are a lot of other books, like different authors, like on MATLAB. Those you can use. Lot of other authors, like if you search books on MATLAB, like there will be five. MATLAB, numerical computations for MATLAB. If you search, there will be a lot of books which are available. You can use them. But these two texts which are given in the course description, I couldn't find them. I don't know. Like,
Okay,
whatever
sir.
the sources I know, I couldn't get them. You can get like some other books, like not from the same authors, like similar kind of books, like applied numerical methods or something. Like there will be a lot of other books. If you want those kind of books, I can share. Like,
Yeah, please, sir.
okay, I'll check. Like, I'll check what which book is better. I'll see and share. Okay, I'll just share again. Okay, fine. That someone asked some other question, right? Pritam Chakravarti is here. He has left. So you can just import like in MATLAB online. It's not a problem. If you want to import some file, Basically, I have institute access. Like I'll just use it. Say open MATLAB one. So this is like unlimited access. I can use this. If your institute provides this kind of access, then you can use MATLAB online without any limit. Or also you can download it on your PC and you can use. So here uh, in files, you can just say go new, and you can say uh, open. Yeah, you can say open. From here you can also import data. This is also showing MATLAB. Right? I can import here. Fine. Yes. Yeah. In MATLAB drive, I think. Yeah. Here in MATLAB drive, I can upload some folders or files whichever I have. Like in MATLAB drive, first I have to upload this. Let's say in this sign. So I have to upload it in the MATLAB drive. Then I can do it. Open in MATLAB. Yeah. So now this is imported. So that's how like you have to go to the MATLAB drive, drive.matlablabs.com, and then you have to upload it. Uh, MATLAB drive. here you can upload. Okay, so from there you can upload. So that's how you can use. Uh, Let me check everything is there. Okay, that's how you can use MATLAB online. So uh, like any of you is using Octave or you are using MATLAB, like or you have access to MATLAB like on the desktop, which like desktop or online you are using MATLAB online, whatever. You can type in the chat box whatever you are using. Are you using Octave or are you using MATLAB online or are you using on PC?
Since I was using till today, I said no. From 5 o'clock, it has stopped. I have to just see both Octave and
Uh,
MATLAB
you
online
can use
version. Both.
where are you using Octave?
Because actually, no, I have signed in for one more course.
Uh,
Their professor was teaching symbolic calculation. So in online versions of MATLAB, that was not available. So I just tried for Octave. There
okay,
it
okay,
was, then access was there for symbolic computation.
okay, okay.
Actually, I will do. So now today it is unfortunately both are not working from 5 p.m. Yes, I
Uh,
have to see. Yeah, thank you.
I think Octave you can download and use. Uh, there might be like you can search online. You can download and use Octave. That is open source. Actually. You can use some online. So that's whatever the in this week which we have discussed. Everything revolved around these things only. So there are this round of errors and also there are this truncation errors. So truncation errors, as I've said, like if you want to reduce the truncation errors, you have to increase the number of things, basically. So rounding of errors, like basically you have to uh, take take care of this step size. Like if your step size is like smaller and it is like yielding some values which are lesser than the machine precision, then you might get truncation errors. So, and we have also seen like these are the direct and the different direct methods and also the numeric iterative methods. So, direct methods like you are like in one step you will get the answer whatever you want to try to like if I want to do uh, Taylor series expansion and get the answer like it is just one step. Like, of course, I have different paths, but like this is just one step. So, in iterative methods, what you do is like you will go step by step. Like if you want to calculate the square root of 10, uh, like numerically, you can do this Nirvan's algorithm. So it's just basically like you can use this Newton-Raphson method, like x minus uh, xn plus 1 is equals to x minus n minus x by f dash of x. Like that. So we can use this like iterative method. Like first, I'll have like let's say 10 steps. So I'll go from first to second step. I'll get some answer which will not be exact. Then I'll go from second to third step, and then I'll go. It's like if you want to like like if you want to go down from a building, either you can jump or you can use the steps. Like similarly here also, like if you are using steps, it will be safer and you will go like in a smoother manner. Like you will have like if you have big steps also it will be a problem because like you maybe like you might slip. So this is also a problem with numerical methods. Like you cannot take too big of steps. Like too small of steps is not a problem with the analysis, but like round of error will occur. Like if my step size is very low, round of error will be occurring. But if my step size is big, you might overshoot and you might not get the like answer. Like maybe in the future. modules, we can see these problems. Like so, step size should be as small as possible, like taking care of the round of error. So, and I should have more number of steps in iterative methods to get nearer to the what you said, true value. Like if I say, I think I have the code. Uh, what is this? Iterative. Just, so what we are doing here, like we want to calculate the square root of 2. So initially we will say, like we will assume this value of square root of 2 is 0.1. We don't know, like we don't know what is the value of square root of 2. We'll assume that this is like uh, square root of 2 only, right? Yeah. So we'll assume that this value is 0.1, but this is not right. So we will perform this numerical computation, iterative computation using this Heron's formula, which we have half into x plus 2 by x. So, and while computing this for each step, I'm also calculating the error. So, see, initially, like in the first step, my error is more. Then I go to the next step, like xi plus 1. Then I'll go to xi plus 2, and then I'll go to xi plus 4, and then I'll go to xi plus 5. So, as I'm going, like, uh, as I'm taking more and more number of steps, I'm going towards like uh, my error is reducing. It means like I'm getting the value of the square root of 2, approximate value of square root of 2, nearer to the true solution, whatever they say. So iterative methods are like that. Like so, iterative methods, when we use these iterative methods, especially when we want to get like solve some nonlinear equations. Like if you have linear equations, you can directly solve. So nonlinear equations inherently, like you cannot solve analytically sometimes. So implicit like kind of stuff will be there. Like we'll see. Let's say if you have like something like sin x, like you can't calculate. Sin x is a nonlinear function. Let's if you have x square plus 5 or something like that, then you can like do it. But like some what we said transcendental functions, right? So you have something like sin x, e power x. So solution to that you cannot get in an exact sense. So lot of times you cannot get do this nonlinear equations. You want to do the solutions, like we have to use the iterative methods. So there is no other way. Like you can use Newton-Raphson or some other methods. Lot of other methods are there. We will, as we go on in this course, we'll learn them. So, and we have also seen this stepwise method. Like we want to calculate the value of f of x plus like f of a plus nh, but we are going in stepwise. Like first we are calculating the value of f of a, then you are calculating the f of we are calculating the value of f of a plus h. And using the value of f of a plus h, you can calculate the value of f of a into 2h. So stepwise methods are also we have seen, like there is some order of accuracy for each thing. So we have seen lot of examples like in the course modules, like order of accuracy. So so whenever whatever the power of h you are getting up in the error term is your order of accuracy. So if you are getting h square here, then it means like your error will have order of h square. It means like as your h decreases by some value, your error will be decreasing by h square value. Like if if you are if you are having like h like this, it means like if your step size is increasing, if step size is decreasing by 10, let's say, then your error will also will decrease by a uh, order of 10. So like that is the order of approximation, or like you can say, we can take like this, like in this Taylor series, this is h plus h is equals to n plus 1, or you can like whatever the value you take, if let's say if you are truncating it to 7 terms, your error will be of the order O of h power 8. So O of h power 8. So like for different methods, there will be different order of approximation. So it's like we have seen this log plots plotted, I think log plot, I think McLaurin series, I have plotted there. You can see. So for basically like we have uh, different, like for 3 terms in the series we are doing it. I think A all, and yeah, and we have that all. Very good. Yeah. So you can see that the slope is increasing, right? So initially my slope will be, let's say, this, as I am taking like uh, as I'm taking, like initially this will be the slope for the first. If I'm taking only the first term, this will be my slope. If I am taking other term, adding the other term, you can see my order of approximation is increasing. Like this line, the slope of this line is increasing, uh, which means my error is getting at a faster rate than before. If my like if it is h only, it means like then this slope and this slope will be same. But in Maclaurin series, this will be of h order of h of n plus 1. So that's why the slope of line is increasing as I increase the number of terms. So my error will be decreasing at more faster rate. So that's the intention of drawing this plot. Slope will be higher when I take even more number of terms. Let's say if I take 4, so now you can see. So initially this, then this, then this. So as I increase the number of terms, my error should reduce. Error should reduce, but also the order of convergence is also, this line is also having a slope higher than the lines for lesser number of terms, because as I've said, order of convergence will be h n plus 1. So it should substantially like improve my accuracy. So that's the meaning of this. So I hope you have understood what is this order of approximation. Okay. I think like today we can stop here. The time is up. You have any other doubts? Anyone else? Or
Hello, sir.
yeah, Nilesh.
Sir, sorry, sir, I joined late. I am not didn't remember this meeting.
Okay,
Uh,
no problem.
I have
Yeah.
one doubt in assignment question. You may take in a graded assignment, or you may take from the non-graded assignment. Example number 3.
Okay.
Assignment 3.
Let's say non-graded. I think we have discussed
Uh,
that one, right? Yeah, this one.
This one. I didn't get answer which were given in options. Why I didn't know. I have tried many times.
Nasir, this was the same problem which you asked, right?
Yes, in forum.
Nasir, are you here?
If you have written code for that example, can you show once so I will understood my
So we have
mistake
written a code
maybe.
for this. What is this? Yeah. See, here you have to use this function format long. Okay. So
Okay.
that will give you more number of terms. So, uh, so
3
the
into x
solution which I am
val minus.
getting, see, otherwise you will get 9146 only. Like for all the terms, it will be rounded off. But if you want more number of decimals, you have to use this format long. Then you will get lot more number of values. Okay.
Okay, format log which step you have taken? 10 raised to what? H is
10
what?
power minus 2 to 10 power minus 8.
Minus 8. Acha, x val is okay, zero point 0.4.
Yeah, whatever it is given there, I have taken.
Okay, log space h val.
The log space is nothing but like you are taking values from 10 power minus 2 to 10 power minus 8. 10 power minus 2, 10 power minus 3, 10 power minus 4.
Okay. Okay, I will try from this format by taking format log. Then I will try, maybe
Nasir,
maybe
are
correct.
you there? Maybe he is not here. Okay. So what was like you were not getting the answer, right? That's a problem.
Okay, sir. Thank you.
Okay. Okay. Is there anything else? Anyone else want to ask? Otherwise, we'll stop for now.
No, sir.
Okay. Okay, guys. Thanks for joining. We'll meet in the next week. I hope I could help you or to solve your problems, whatever you have. Uh, so one thing is like if you want some have any doubts, you can also write a mail to. Yeah, this is my mail ID. Because sometimes I won't check this discussion forum. So maybe I'll do it. So you can use this email ID. I'll also share this chat box. You first try to put it in the discussion forum. If nobody else is answering the question, you can send it to me because like I might not be checking this discussion forum very frequently, but I'll check my mails. So if you have any doubts, you can send it. Like not only related to this course, if you want some other things, some other purpose, like you can help. Like you can ask me, like whatever I can do, I can. Like I'll try and help. Yeah. Chalo, chalo. Thank you. Good night,
Yes,
guys.
thank you, sir.
Thank you, sir.